9.2. Now we talk about translation in y direction. Now we can talk about translation in the x direction. We use the same graph, y equals x cubed. Y equals x cubed. Again, we can have the table. What happens if I want to sketch x plus 3? That means again I replace x with x plus 3. Now I do a reverse way. Look what I covered is the x coordinate. Now you ask yourself, in order to get a same y coordinate of 27 on your left, what should be your x? 0. Because 0 plus 3 to about 3 to get 27. I should get 0. In order to get y equals to 0 here, what do I get? I need to substitute x equals to negative 3. Of course, the rest you can find. Now, what is the observation here? The observation is very simple. Look here, this set of coordinates and this set of coordinates. What happens to that? Minus. So, when I replace x with x plus 3, it is actually a translation in the negative x. Okay, so translation 3 units in the negative x direction. All right. Okay, a bit wordy stuff here, but essentially we all know what we are talking about. If fx equals to x cubed, then definitely f2 is 8. Now, if fx plus 3 equals to 8, to get the same y coordinate of 8, for example, to get the same y coordinate, what should I substitute x here? X should be negative 1. So, from 2, for the x coordinate of 2, it becomes negative 1. So, it's actually a translation of negative 3 units in the negative x direction. Don't understand the words, you can go back and read. It really is okay. Okay? What I want you to note is just, more importantly, is actually you understand this table. This table is more important than the words. If you understand the table, the words is fine. Okay? All you want to observe is that from here to here, it is all the x coordinates are minus 3 for all the x coordinates. So, every single point hk, every single point hk, now your x coordinate becomes h minus 3. Okay? So now suppose it's not 3. Suppose I have y equals fx. Y equals to fx. And now I want to transform this into y equals to fx plus b. What is this transformation? You know? Yes? Can I? Can I? So it is a translation of b units in the negative x direction. Very good. This one, of course, will be in the positive x direction. Okay, so this one is also quite obvious. If fx is changed to fx minus b, alright, what x will actually be replaced by x minus b, and it's a translation. And this table essentially is just for your reference when you revise, all right? And then again I repeat, there's no real need to memorize. There's no real need to memorize. Okay, nothing beats being a bit more concrete. Now, what I did here is, let me explain what is this about. What I did is, I sketched, the black ones are the original graph, y equals fx. Okay? That means this is the x2 graph, this is the sine graph, this is the mod graph. No problem. If you take a look at the colored lines, these are the y plus b equals fx. And what is b? B is 2.5 for this case. Right? So if it is 2.5, y plus 2.5, you actually translate downwards by 2.5. So I can vary the value of b. And you look at all the three graphs like that, they are actually translating downwards. What if b is negative? What do you expect? Upwards, of course. Now let's take a look at the same three graphs now. Again, the black ones are the original. The colored ones are the transformed graphs. So if b equals to 0.5, that means y equals to fx plus 0.5. It is actually a translation to 0.5 units to the left, not the right. So if you take a look, as I increase my b, it moves away to the left. Of course, we all know what happens to the graph when b is negative. See negative here. Then it actually translates to the right. Regardless what is the function. It can be sine, it can be mod, it can be whatever. Do you follow? Yes? Okay, example 3.